Hey there. I wanted to come back and I want to look at um, a problem with you. Hmm, maybe this. Yeah, I want to look at this problem with you. So I've got a graph, and this is a graph of f, and f of x goes wee, and then bounces and goes down. Okay? And I've got a point here called a point here called b, a point here called c, and a point here called D. Ooh, there seems to be a point here called H. And this is E, and this is J. Okay, so here's what I think may help. In the video for assignment 64, we had a problem like this, and we were asked questions like, when do f and f prime have the same sign? Remember that one? Well, I think what I want to do is build a little graphic organizer that has A, B, C, D, E, H, and J. And we can have an F prime, an F double prime. And I actually think that if you have a bunch of these questions to answer like we did in that video for 64, it may actually be really, really, really worth the time to fill in this table. So F is given. F is 0, F is positive, F is 0, F is negative, F is 0, F is negative, and J is negative. Okay? And then, what about F prime? Well, F prime is positive when F is increasing. So at A, I have a positive. At B, the slope here is 0. At C, I have a negative slope on F. At H, I have a negative slope. At D, I have a 0 slope. At E, I have a 0 slope. And at J, I have a negative slope. And what about F double prime? F double prime is concave down from A to C. So concave down means F double prime is negative, F double prime is negative. But here, where I go from concave down to concave up, I think that's 0. At D, F is concave up, so that's plus. At E, F is concave down. At J, F is concave down. And what about at H? Well, if that's my inflection point, then that's going to be part of concave up, and so I've got positive. Now, let's go back and answer some of those questions. I'm looking to know when f prime and f double prime have the same sign. No, 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 yes. It's very easy, yes, at x equals j, to do these problems when you have this graphic organizer. When is f got the same sign as f double prime? No, no. Well, you could make an argument for that. No, 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 yes. Okay. When does f equal f prime? Have the same sign, rather. No, 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 no. Sure. Definitely. Definitely. Okay? Build the graphic organizer. You'll be so much happier if you do. Okay? I want to take a look at this old AP question from 1996. I know it's really old. I wasn't teaching calculus then, but Mr. Surkey, you guys know Mr. Surkey? Yeah, Mr. Surkey was teaching calculus at this time. I think he was. Maybe he had already retired. Oh my goodness, he was teaching calculus when I was born. That guy is wicked smart. So if you need some help, reach out to Mr. Surkey. All right, so here's the problem. I believe this problem is actually in our Chapter 5 folder in assignments. It's called 1996. This old numeration, so don't freak out about that. And one of the things about AP problems is that a free response question like this We're expected to be done in 15 minutes. All right, so let's see what we can do with it. This is a graph of f prime. Okay, that's what that says. But wait, note, this is a graph of the derivative of f. This is not the graph of f. So they've told me that I'm looking at f prime once, twice. The figure above shows the graph of f prime. 3 times they told me, before they told me anything else, that this was a graph of f prime. And you know what that means? That means a lot of American students are either really stupid or really, really stressed when they go take this test, because they need 1, 2, 3 reminders that this is f prime. Okay, I got you. Stop screaming at me. This is f prime. The domain of f is all real numbers from -3 to 5. So we're only looking here at what we see on the graph. For what values of f does f have a relative maximum? This is not f. These are not maximums on f. This is f prime. You might feel better if you wrote an f prime sign chart. Okay? F prime equals 0 at -2, f prime equals 0 at 1, and f prime equals 0 at 3, and maybe, yeah, well, that's all I've got. What, f prime? No, Kukla, stop it. That's right, but this should be a 4. Okay, so what can we say? Here's f prime. F prime from -3 to -2, f prime is above the x-axis, so f prime is positive. From -2 to +1, f prime is, right, it's got all those negative values, and from 1 to 4, more negative values, and from 4 to 5, we've got a bunch of positive values. I think it's probably smart to put in those endpoints. Though, remember, here, no could be equal to's, right? So I'm going up to, but not including these points. All right, so our question here, part A, for what values does f have a relative max? Max. When f prime goes from negative to positive, f has a max. Don't forget to write the justification. Look, see the word? The word is y. Y is our justification sentence. There is a max at x equals -2 because to the left of x equals -2, f prime is greater than 0, and to the right of x equals -2, f prime is less than 0. And there we've got our max and our justification. Now, remember what we said about finding maxes and mins? We said we would look to see where f prime was 0, and we would look to see where f prime was undefined. But here we're told that this function is defined everywhere on this interval. So and we don't know, we don't see any, do you see any vertical slopes here? No. So we know that f prime is never undefined. But where was the third place we looked for maxes and mins besides f prime equals 0 and f prime undefined? That's right. That third place that we look are the endpoints of a bounded interval. But look what they did in the stem of the problem. And you know why they did that in the stem of the problem? Because there are a lot of American kids who don't remember to check the endpoints. And they're explicitly telling you, yeah, you don't have to worry about checking the endpoints here. Oh, how weaselly. Okay, so my experience with Sabino students is Sabino students think, oh, look, -3 is a min because to the right of -3, f prime is positive, so f is increasing. So this must be the low point. Like, our kids, our students, you fabulous people, are not afraid to think about what's happening at endpoints. But College Board says, no, dude, that's going to be too hard for them. And so we only have one max. Part B. For what values of x does f have a relative minimum? Well, I have a minimum when f prime goes from negative to positive. There's a minimum. There is a min at x equals 4 on f of x because to the left of x equals 4, f prime is less than 0, and to the right of f equals x equals 4, f prime is greater than 0. So that's part A and B. Part C, on what intervals is f concave up? Look, use f prime to justify your answer. They don't want us appealing to f double prime. See, look, they've given us a graph of f prime. They even told us this 3 times. And then down here they say, on what intervals is f concave up? Use f prime. Don't say anything about f double prime greater than 0. Or, yeah, no. We have to talk about f prime. So remember, if f is concave up, we know that means that f double prime is greater than 0. But f double prime is simply the slopes of f prime. If f double prime is positive, that means the slopes of f prime are positive. And if my function has positive slopes, then I know f prime is increasing. And so when they ask me about when is this happening, and they give me f prime, I have to say, well, f prime is concave up when, f is concave up when f prime is increasing. So I look at this graph, decreasing, 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 increasing, increasing, increasing. So f is concave up on -1 to 1, and decreasing, 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 increasing, increasing, increasing from 3 to 5. Union 3 to 5, because f prime is increasing on these intervals. Fabulous. Okay, last thing they say is suppose that f of 1 equals 0. Sketch a graph that shows the shape of the graph of the function on the open interval from 0 to 2. I don't even need to do the whole thing. And guess what? American kids need 0 to 2. Sabino calculus students, for them, they're drawing the whole damn graph. And they lose points because we only wanted 0 to 2. So let's see what we can do with 0 to 2. Okay, so 0 to 2. Well, what do I know is happening? I know I have a 0 slope at x equals 1, and I know that f is decreasing, has a 0 slope, and then decreasing. Okay, so what does that look like? F is decreasing to a 0 slope. There's my 0 slope at 1, and decreasing again. Now, you might say, well, Mr. Kukla, couldn't it be some other things? 0 and 2. Open interval. Okay. There's my graph. Couldn't it be other things? Couldn't we be decreasing like that? And then decreasing again? Well, so here's the problem with that. F prime, the slopes of this f graph, at x equals 1 are 0. That's not a 0 slope. That's an undefined slope there. I have a very negative slope here and a 0 slope here. No, negative doesn't equal 0. What if I did this? Could I do this? Could my graph look like that? At x equals 1? No. Why not? Well, what's the slope here on f? That's a stupidly vertical slope. I need a slope of 0. So even though they haven't explicitly given me information about f double prime to think about concavity, I know that f is differentiable. They gave me a graph of f prime that existed everywhere. That means, since the derivative of f exists everywhere, that means that f double prime must exist everywhere. So, what can we say? Well, it has to be this, and that's x equals 1. And I don't care if you put it here, or if you put it here. Do I care? Oh, f of 1 equals 0. So that's actually the ordered pair 1, 0. So this and this. And that's my value, open circle, and open circle here at 2. There we go. That's my graph. Okay, you can do this AP exam. You can rock this AP exam. Really, you can. But if you're not comfortable with the stuff here and in the video for 64, yeah, it's going to be hard work. So my recommendation is you actually take some time to make sure that you actually own all this stuff. See this packet? Summary time, these notes. This goes through all the different justifications you need to be able to do, all the things you're supposed to know. Yeah. And this thing, man, you should have this cold. Like, fill it out in less than a half hour. And it probably won't be a half hour the first time you do it. You may well need to do this a number of times before you can do it fast. But that's okay. We want you to get comfortable with this knowledge. All right. I can't wait to do many, many, many more AP free response questions with you. I'll see you in the next video.